A solar eclipse is a moment of wonder, a rare and fleeting event when the moon passes between the Earth and the Sun, casting a shadow upon our world. For us on Earth, it's a breathtaking celestial dance where light bends and time seems to pause. But what if we could look at this cosmic performance from other worlds? What if we could watch this event unfold across the vast reaches of the solar system, each planet offering its own unique perspective of this universal phenomenon? Across the infinite expanse of space, every world experiences the eclipse differently. The harsh glare of the sun, the way light is filtered or scattered, and the way shadows move. Each planet provides its own signature performance in this celestial theater. Today, let's travel to each planet and imagine how a solar eclipse would appear, unfolding through the distinct lens of each world. And in doing so, we may better understand not only the nature of the eclipse, but also the uniqueness of the planets themselves. On Mercury, a solar eclipse would be a breathtakingly intense and surreal event. The sun, nearly 3 times larger in the sky than we see from Earth, dominates this airless world, its light unyielding and fierce. There is no atmosphere to soften its rays, no clouds to scatter the sunlight. And so, when a moon crosses the sun's path, if such a moon existed, the eclipse would be startling, abrupt, and dramatic. The suddenness with which light would vanish and then return would be harsh and unsettling, as though a great cosmic switch had been flipped. With no gentle transition, the shadow would cut across the surface of Mercury, and then just as quickly, the sun would re-emerge, even more blinding than before. It would be an eclipse of sharp contrasts, of extremes, darkness falling like a shadow cast in stone, only to be swallowed whole by the sun's unforgiving glow. On Venus, the eclipse would be a ghostly and elusive experience. The thick, sulfurous clouds that blanket this world are impenetrable, hiding the sun almost entirely from view. Even without an eclipse, Venus's sky remains a muted, smoky yellow, bathed in a faint, dim light. But when a moon crosses in front of the sun, it would not create the sharp contrast we are familiar with. Instead, the eclipse would be a quiet, subtle dimming, a retreat into a hazy, almost surreal twilight. The sun, already filtered through the toxic clouds, would grow even more distant and hidden. The change would be gradual, and yet somehow profound, as if Venus herself were pulling the curtain across her skies, allowing the eclipse to pass in shadows and whispers. It would be a muted, mysterious eclipse, wrapped in an atmosphere that muffles the very essence of light. On Mars, a solar eclipse would be fleeting, an ephemeral moment of dimmed light, barely noticeable but unforgettable in its subtlety. With the Martian atmosphere so thin, there is little to filter the sunlight. And yet, the sun appears small in the sky, its light weak and distant. When Phobos moves in front of it, the eclipse is not a sudden plunge into darkness, but rather a soft and gradual fading. The shadow of Phobos races quickly across the surface, casting a momentary pall over the red deserts and rust-colored valleys. The dimming of the sun would feel almost like the planet itself is holding its breath, just a brief, quiet pause in the Martian day before the sunlight gently returns. The experience would be one of calmness, as though time itself had slowed down to witness the eclipse. On Jupiter, the eclipse would be a majestic and awe-inspiring event. The planet's immense size dwarfs everything around it. The sun appears as just a small, faint disk in the vast sky. When one of Jupiter's moons, such as Io, crosses the sun's path, the eclipse would not be a fleeting event. Rather, it would be drawn out, the shadow slowly creeping across the planet's vast and ever-moving cloud tops. The light would dim gradually as the sun's rays are obscured by Io's shadow, and the clouds beneath would take on a soft, muted hue. The contrast between light and shadow would be gentle, as if the eclipse is part of the slow, rhythmic dance of the cosmos. On Jupiter, the eclipse would be less about darkness and more about the slow unfolding of a quiet cosmic moment, a reflection of the immense scale of the planet and the universe itself. On Saturn, a solar eclipse would be nothing short of spectacular, a cosmic masterpiece painted across the canvas of space. Saturn's rings, with their delicate ice and dust particles, would scatter the light in dazzling patterns, creating a luminous halo around the shadow of Titan, Saturn's largest moon, as it crosses the sun. The moment the eclipse begins, the sun's light would soften, dimming not only Saturn's surface but also the shimmering rings that encircle the planet. The shadows would ripple through the rings themselves, transforming them into a sea of flickering light and dark, a beautiful play of cosmic geometry. Titan's thick atmosphere would also filter the sunlight, creating a subtle, muted glow. The eclipse would feel like a celestial ballet, the planet's rings acting as the stage and Titan as the performer, moving gracefully across the sun in front of a silent audience of moons and stars. Uranus, with its strange tilt and distant, pale blue glow, offers an eclipse like no other. The planet's axis is tipped so dramatically that its poles are nearly pointed directly at the sun, creating an entirely different experience of light and shadow. As Miranda, one of Uranus's moons, crosses the sun, the eclipse would feel disorienting. The angle at which the shadow falls would depend on where you are on the planet, with long, slanted shadows stretching across the icy, cloud-swirled surface. The sunlight would dim, but not as dramatically as on other worlds. Instead, the entire atmosphere would shift, taking on an eerie, quiet quality as the sun becomes partially obscured. The eclipse on Uranus would be unlike any other, a strange and tilted perspective that leaves you pondering the mysteries of the universe. And finally, on Neptune, the solar eclipse would be a quiet, distant moment, a fleeting touch of darkness in a world far from the sun. With the sun so far away, the eclipse would not be dramatic, nor would it bring about a sudden shift in light. Instead, Neptune's deep blue clouds would darken ever so slightly, casting a shadow over the planet's stormy, icy surface. The atmosphere, thick and turbulent, would scatter the fading light, creating a cold, eerie twilight. The eclipse on Neptune would feel like a whisper, faint and almost imperceptible, before the sun reappears, distant and small in the sky, and the planet once again returns to its endless storm-filled silence. From the blazing proximity of Mercury to the far-reaching chill of Neptune, the solar eclipse is a moment of profound beauty, uniquely experienced on every world. It is a reminder of the vastness of our universe and the way light, shadow, and time weave together to create something larger than we can truly grasp. Each planet, each world, offers its own distinct view of this celestial event, one that speaks to the mystery and wonder that lie just beyond the reach of our understanding. And as we gaze into the infinite cosmos, we realize that we are all part of this cosmic dance, a dance that will continue long after we are gone, painting shadows and light across the expanse of space.